Okay, hi everyone. I'm glad to start this new season for our reading groups. So I'm gonna talk today about the paper which tries to synthesize images from text. I think this paper appeared 2016 in ICML. Okay, so the paper originally is titled Generative Adversarial Text-to-Image Synthesis. So what they are trying to solve is that given some text, like here Max Wolf is white and likes walking in snow, given this text they try to generate an image that is as faithful as possible to the text description. Of course it may seem very intimidating and very hard task, but the author here tried to use some existing tools and combine some architectures from deep learning and adversarial learning to try to solve this task. So originally the paper is written by Scott Reed and others. Okay, all right. Okay, so the starting point is GANs. So last year, for our reading group, I presented the original paper on GANs. So the objective of GANs, which means generative adversarial networks, for people who are not familiar with it, the idea is that we would like to train some generator. So the generator is something that will generate some data samples like images, text, or any other kind of images. You can think of it as a sampler or as a simulator, right? So this is the generator. Now, the way GAN trains this generator is that they use some real example. Let's say, for example, you would like to generate images that look like real images. So the way GAN proceeds, first they will build a database of real images, like this one for example, and then they will start to train some generator that will take some noise as input and output some image. And what they do is that they compare the output of the generator to the real image. If they look similar, then they will retain somehow. If they don't look similar, then they will. The idea is to keep updating the generator until it's able to generate something that looks like real images. Now, the way they do this comparison is by introducing some discriminator. So the discriminator takes as input an image. So in the beginning, he doesn't know whether it comes from real or fake. But based on his knowledge, he will try to assign this image to the fake or real, right? Now, the objective of this generator is to try to fool this discriminator to assign his images, the fake one, to the real class. Okay, so basically the idea that you need to retain, so I guess most of you are familiar with the traditional concept of learning. You define some objective and you try to find the best solution of this objective by minimizing. Here is a different style of learning. We perform learning by comparison, right? So that's the whole idea. Now, the current paper will build on this framework of GANs to be able to synthesize images from text. Now, why do they choose to build on this framework? Because so far, this is the state-of-the-art approach that allows you to generate sharp images. Images that look very similar to real images. Like images that can mistakenly taken for real one. Okay. Now, let's try to build step by step this image synthesis GANs. Now, the first and naive solution is to consider what is called in the community conditional gap. What does it mean? It means like conditional on something, I will try to generate something else, right? So here the conditioning naturally will be the text, for example, assume that we have some text here. This tiger looks hungry, and we would like to condition our generator on this information to generate a tiger that looks hungry, right? So this is what they call conditional gap. Now, the concept is the same. You can think of it this way. Instead of trying to discriminate two types of images, you can think of it this time as trying to discriminate between pairs of examples. Now, the pairs here are images plus some text embeddings, right? So the way we would proceed, we have some sentence or caption or description. We use some text encoder to get some dense representation or vector representation of this text. Then this text, along with some noise, will be fed into the generator. Who will try to generate some images. So I emphasize that the generator here only tries to generate the image. Now, for the discriminator, what we're going to do, we will feed the images that we have, either real or fake, plus the right text, like the text embedding. And the objective of the discriminator is to say whether this pair is real or not, right? This is the basic architecture, what they call conditional gap. I mean, somehow it's not true, but you can think of it as some form of join gap. It's not exactly join gap because the generator doesn't generate the text, right? Only the discriminator takes as input two things, pairs, text plus image. Now, is there any question at this point?
Okay, so the texts are different, right? The one with the real tiger and the fake tiger.
Oh, they are the same. They are aligned.
Text.
Yeah, the same one. Yeah. Now, of course, this may seem straightforward and may look reasonable, but actually there is a serious issue with this naive architecture. Now, what is the problem? The image may not align with text, and I guess is somehow related to Prof's question. The image may not align with the text. Why? Because if you input, as long as you input some text which is right text, which looks like real text, because we are not generating the text, we always input to the discriminator the right text. So as long as we input some right text plus some real looking images to the discriminator, he will put it in the real class, even if they don't align with each other. So if you put something like this is a nice car, the show-off thing, then the discriminator will take it for real because the image look real and the text looks real as well to him, right? So in order to fix this, the author proposed to alter this architecture a little bit. Now, what is the principle? The principle is to train the discriminator to align text with images. That's the whole idea. Now, the way they will do this, the way they solve this is very simple. They just say, okay, now we will try to augment a little bit our set of fake examples. So they introduce what they call the wrong text. So given an image or given some caption of the image along with its caption, they will try to build the embedding as in conditional gap. Now, in addition to this right caption, they will pick somehow at random in the corpus some negative caption or some wrong caption. They will also build the embedding. Now, what will happen is that the generator will always take the right text and the noise and try to generate the image corresponding to it. The discriminator will always take pairs of text embeddings and images, but we will add another type of fake pairs. The fake pairs are real images plus wrong text. So we will train the generator, the discriminator, to classify this kind of examples in the wrong class. Now, what will happen here is that the discriminator will somehow learn somehow learn to decide whether some image and text are aligned with each other or not. No, because the discriminator learns this feature, and knowing that the generator always tries to fool the generator, so implicitly the generator will try to always align the image with the text embedding. So that's the whole idea. I mean, it's simple, but this is the way, just by introducing a new form of examples, they would try to solve this problem where the images may not align with the corresponding text. Now, this is why in the previous slide I was saying you can think of it as a join, as trying to discriminate join pairs. Now, by the time you come into this join pair examples, you may have a lot of possibilities, like real plus right, fake plus right, real plus wrong, right? Now, of course, they don't consider fake plus fake because the objective is to standardize a real image given some right text, right? Any question?
Why would you ever have the wrong one? Because your training data will always have the right one.
Oh, so here, for example, if we present this example, we present a real image with wrong text.
So the previous slides, when does this ever happen?
Oh, this never happened.
No, the next one. The nice car and the tiger.
Oh, this one. Oh, this one will be actually. This one will be here, for example.
Right.
Yeah. This will be, for example, here. This is the red car with white dots, something like this. Yeah.
Okay, but during training, you already have the right ones.
Oh yeah, we have them. Yeah, yeah. But in addition to those right ones, we will provide to the discriminator some example like this, where we have a real-looking image with the wrong text. Because previously, if we input a real image to the discriminator with some text, he will accept it as real. But if we tell him, if we add this kind of example, we will try to encourage the discriminator to check whether the text aligns with the image or not.
So now you're saying there's three types of inputs: real and right from some data set,
Yeah.
and real and wrong from some data set,
Yeah.
and fake and real and right from the generator.
Okay. Fake plus right.
From the generator.
Yeah. So the generator only outputs images.
Okay.
So this is why this arrow here
So what
enters
does the generator generate?
images, the
Text.
fake images.
Okay.
But I think it's a bit confused because you group the fake and right and the real and wrong. I think it should be three line, real and right.
Yeah, definitely.
Fake, yeah, real and
Yeah,
wrong.
yeah,
And
yeah.
that's what, because the generator just generate the fake image.
Exactly. This is why this arrow enters.
Yeah, but it's a box. It does box. Yeah.
That's true. Yeah, exactly. Yeah, I agree. The presentation here is a bit confusing. Yeah, the generator we only generate images. We never generate text. But here I just represent the fake examples. What is considered to be fake? What is supposed to be considered to be fake by the discriminator? Okay. Any more questions?
So there are. How does the classification proceed? So you have three pairs now. Then for each image, you decide whether it's real, fake, or
Oh, so it decides for the pairs.
for the pairs.
Yeah. So each time we will input a pair of text embedding plus image, and the discriminator has to predict whether this is a real pair or a fake pair. So another way to think of it is to think of the text as a context, and the discriminator will try to decide, given this context, is this image real or not?
So the label is always there is a label here, right?
Yeah, yeah.
And the label is for a pair.
Yeah, exactly.
For a pair meaning you decide for image and text, or you decide combining it. It's
Oh, actually in this setting you decide for image given text in reality. Yeah. So like this one, when you input this one, given this text, this one will be treated as fake. All right. Okay. So they also proposed to introduce what they call interpolation. So interpolation is in the text embedding space. What does it mean? So they would like to learn a smooth manifold of the text representation. Like if I move a little bit, then I should get only small variation of my text. Like let's say for example, if I say this tiger look hungry, then if I move a little bit, I change a little bit the text embedding, then I may end up with this tiger is angry instead, right? It should not be something completely different. Now, what will happen here is that instead of training the generator this time only with one text embedding, they will try to combine two captions at a time, right? We can discuss further how do they select those two captions, but mainly one caption is the right one, and then they pick another one. Actually, they say it can be completely different from this one, and according to them, it doesn't lead to any issue, but I think is arguable. So the idea is that they combine these two embeddings, and then they input it to the generator to synthesize the image that correspond to this embedding. Now, this embedding might not correspond to any text in the corpus. It may be some variant that we never observe. Now, why should this work? Because the discriminator always try to check whether an image aligns with text to push it in the right class, right? So because the discriminator tried to solve this problem, the generator has to always align the image with the combined or with the interpolated text to fool the discriminator. Because if it doesn't satisfy this condition, the discriminator will always push it to the fake class. So that's the whole idea of this interpolation, is to learn a better manifold, a smoother, and a manifold where you don't have like holes, where you don't cover some area of that manifold. Yeah, it's more like you can think of it as some trick to learn more robust representations. Okay, now they combine everything together, and they do both. They do both the interpolation and the real plus wrong examples. So at the end, they have three kinds of fake pairs: fake plus right, real plus wrong, fake plus interpolated text. Yeah. All right, here are some experiments. I think the paper is mainly based on qualitative experiments, not too much of quantitative one. But here they give few examples where they describe some birds with some features, and they try to generate a series of images that that correspond to the description. Now, on tasks like this, it seems to work a little bit, but they do recognize like they choose images which are not that complicated and which are easy to work with. They also tried on images. The problem is easier. I mean, arguably it's easier for the bird example because somehow the shapes are easy to learn and to capture. The approach seems to give quite interesting results, where the descriptions here seems to look like the generated images. So this one is a real image corresponding to this description. The rest are all generated. Okay, they also tested something. I think I don't have much time to develop it. They call it disentangling style and content. So the basic idea, they wanted to check whether the text embedding is the one who is capturing the content of the image and the noise captures the style. like the position, the background, and things like that. And actually, it seems like the results seem to confirm this intuition, especially the interpolated variants that really separates the noise and the text embedding in terms of the way they use them to synthesize the images. Okay, this is another example of this disentangling style and content. So basically, they just used some images here with some style. They try to generate other images which seems to follow the same style as the given examples. All right, here is about the interpolation. Same, they combine here two sentences and they try to generate the image corresponding to the combination. Here they consider longer images. They may contain more descriptions. Yeah. All right, so in conclusion, I mean, the approach is simple, but it seems like on this problem of flowers and birds, it seems to provide quite interesting results. They show also the architecture really allows to disentangle the style and content, like really uses the noise to control the style and content, while it uses the text embedding for controlling the content of the image itself. They also show that interpolation helps in their case. Yeah. Thanks for your attention.
We have about 4